Hello, welcome back. Last time I solved 3 puzzles and got them all correct on the first run. I've been reminded of a few things. I was playing kind of like risk-aversely because I saw that I was sort of on a streak of like phrasing a program properly and having it work first run, so I didn't want to break that. So I didn't want to try this thing, but I've been told this does indeed work. Looking at this, it makes sense. I was watching while stuff runs here. You see values going like through the arrows here. So this is almost like another register in a way. Yeah. So that's where the value sits on like the input and the output here, and doesn't have to actually pass through ACK here. So this should give me a slightly better score, maybe. Also, apparently you can put labels on the same line as instructions. So go fast. Ooh. I don't know if that improved anything, but it still works. Right. Anyway, so signal edge. Oh, another thing I was real curious about. Speaking of ports, like I noticed that this has an input. Let's mess with it. What if I put something over there? Well, it sits there. I guess that just never reads from it. Okay. I don't know. I feel like there might be like some sneaky way to interface with these, because like why else would they have inputs there? But I mean, like with a port here, they have to actually actively read from it for anything to happen. So I don't know. Yeah, go back. Okay. Anyway, signal edge detector. Create new program. Read a value from it. Compare value to previous value. Write 1 if changed by 10 or more. If not true, write 0 instead. The first output is always 0. All right, great. What do you have to say? 1994 something, and days, cycles and cycles, and just one after another. I'm sick and tired of people who don't respect me. Time to pack it up. Huh. All right then. So here's in, here's out. This shouldn't be too particularly hard, honestly. Compare. Let's start with that. Previous value. Let's just use like one of these for storage, maybe. Right, 1 if changed by 10 or more. Okay, so this is going to be interesting. How will I... First output is always 0. First output is always 0. Now... Is the first input always going to be 0? The first output is always 0. So hang on. So I don't want to then compare. I'll bet for the random run that's going to give me values that don't necessarily start with 0. So yeah, it sounds like this needs to be a special case. So the very first one of these, how can I detect that? Well, I mean, I know that this starts with 0. It's not like it's going to reinitialize between the different sets of test data, right? Do I check like in between the... I guess I'll just let that be 0, compared against 0, and not worry about it. But that seems like... I don't really have a way to detect program start unless like I'd write a value of 1 to some register somewhere and then check against that to see if I need to... Well, I'll just not worry about it for now, I guess. Okay, so compare value to previous value. Previous value will just be 0 if changed by 10 or more in either direction. Yeah, okay. Okay. Oh. Let me take a look at my toolbox for a moment. I mean, it's pretty simple. I think I know what all these are. Haven't had an occasion to use any or last yet. Or NOP. I guess that'd be for like synchronization if I want instructions to... I'm not sure when that would be used. Like just extra instructions for some reason. Move, swap, save, add, sub, neg. Oh. Actually, yes, this is useful. Okay, neg. Thanks for reminding me of that. So that gives me an idea of how to do this. Okay, so I'm just going to have previous value stored over here in the same way as I stored in that previous program. All right, so you're my extra storage. But... So then you probably need... Okay, so I do have a horizontal limit. Good to know. Can I do, like, this? Invalid register 0. Oh, right, it's the other way around. Okay. So that's going to initially store a 0 there, then store whatever comes to... Well, now why am I doing this? No, this makes sense. It'll make sense in a second. So I'm doing this. I need to... Oh, wait. I need to actually stop and think for a moment about this, because it's kind of complicated. Like, I can almost see it, but I'd just be staring at this going, for a while. So let me do that on my own. Okay, I think I see what I want to do, and it doesn't need to involve this. All right, so basically what I want to do is subtract the previous value from the current one. I can probably just do that here, sub up. If it's less than 0, then I want to negate it. Actually, let's do it the other way. If it's greater than 0, then don't negate it. All right. So sub up. Greater than 0. Okay, so I have the absolute value of the difference between the two. So now I want to sub... I think I can sort of... Let's see. Right, that's not how that's spelled. As I go along this path from in to out, I can do some parallelism here. So you're subtracting that from ACK. I need to... save. No, wait, I need to... Oh, this doesn't work. This doesn't work at all. Okay, so I have some problems here. What am I subtracting? I'm subtracting ACK. All right. I did something like this before, but... Alright, so this is going to involve an extra one of these for storage. So I want to... probably want to do this, because I do need to save the previous value without any differences applied to it. So that clearly needs to go in back. So that's fine. Then I'm going to... sub right. So you're going to initially... Well, yeah, this is kind of the same as... Oh boy, this is so hard to think about. And I'm still wondering if I can have it like go along the... Well, I mean, this path is just as good as this path. Okay, so sub right. So right is where I'm storing the previous value, because I need two things I can operate on, but also to store the previous one. So, okay, previous value is in back. I'm saving it here, so that's now the previous value. So now I can operate on ACK and do whatever I want with it and not worry about it. So I'm going to sub right. All right, so I'm still saying that I'm doing that. Okay, so you're just storage, and I'm going to move down around you. All right, so this is equivalent to what I was doing there. So maybe I was on the right track after all. So I don't want to save. I want to swap. So if I have this... I want to swap and then move that to the right. That sounds about right. All right, I'm just going to run this and see what it does. What? What are you saying to me? Wait, okay, so here's what I've done. I did this backwards. All right. Okay, right, so I have I have no actual code to turn the difference into 1 or 0. Okay, so that can go down here. So a little bit of parallelism can happen. So I have the difference in here. I'm going to subtract 10. If you're less than 0, then that means... Okay, let's subtract 9. So if I've subtracted 9... No, yeah, by 10 or more. That's why I'm subtracting 9. So if you subtract 9 and you get a -1 or less, then I'm just choosing letters or labels, I guess, because they're short, so I can put the same, I can put code in the same line. All right, so if it's not a difference, then move 0, right? Otherwise... sure, something like that. I can put them on separate lines if I don't need compactness. You know, that's just more readable. So I'm going to do that by default unless I really need not to. Which again means I can use longer labels. Okay, so that's fine. All right, so that's my logic for seeing if there's a big difference. Perfect. I did, wait. So 9 is wrong. Something's wrong with my thinking about this. This probably should just be 10. That makes more sense. Changed by 10 or more. Also, I seem to have inverted this. All right. All right, that seems fine now. There might be an opportunity for more parallelism here somewhere. And some way to avoid this extra instruction here. But this does work. Yeah, okay, this program could definitely be improved. But it's functional. It's fine. I'll take it. Okay. Cycle count a little bit above average. Instruction count a little bit above average. Node count normal. Okay. Great. I'm satisfied with that. Interrupt handler. What do you have to say? So December 30th, 1994. My sister was over for the holidays. I think to check on me, make sure I haven't gone off the deep end. I know I caused some worry. Her kids saw me working here and suggested I could surf the web for TIS-100 specs. So even kids are on about the internet. Online, blah blah blah, 0x7. It's a racket. I don't care about the information superhighway, and I never will. Let's see, what was the internet in 1994? Different from how it was today, definitely. There wasn't much there at that point. It kind of just like barely existed as we know it now. Read from n.1 through n.4. Alright, so 4 inputs. Write the input number when the value goes from 0 to 1. Oh! 2 interrupts will never change in the same input cycle. What? Goes from 0 to 1. Okay. I think I understand what you're saying. So I just want the index of which one of these changed from 0 to 1 on the current read. Okay, so this is getting into some interesting parallelism. Alright, so these all need to read at once, and then I need to coalesce them into something that understands something. Okay, this is going to be complicated. Interesting. Yeah, so index in.4 changed from 0 to 1 here, so that's that. But if nothing does, then just write 0. Okay. So this is fascinating. Like, the thing I'm thinking about right now is how to collapse this sort of wide set of inputs down to one single column. Like, I have another row that I can use for that. Okay, so once again, I'm going to give myself a moment just to kind of parse through this in my head and come up with a plan for what to do. Alright, I think I have some idea of what I'm doing here. For some reason, I'm having an impulse to try to do this in the minimum number of nodes. So just these 4 and these 2. So the idea right now is... So I'll initialize that to 0. Subtract whatever comes in from the input. If it's less than 0, then I want to go to a label. Alright, I'm going to go back to verbose labels just so I can keep track of things better, unless I really need to tighten up on the amount of text space I'm taking up here. So if it is in fact less than 0, then I've detected that I need to report that you are the one that has a change. So when you do that, I'm going to move 1 to the right. So we're going to have some secondary functions on both of these that read from here and send it on to the appropriate place. These outer ones can just do this normal job, and that's fine. The others of these 3, this one will move 2 to the right, this one will move 3 to the down, this one will move 4 to the left. So they'll print their own numbers. And if they're not, if they haven't changed, they'll move a 0. Alright, so if we're looping there, then that's what's going to happen. That sounds pretty reasonable for these two. So that's all fine. You're going to need... Okay, so you are going to be the most overworked one of these. I think that's fine. Okay, so let's think about how to do this core. So these are the simple ones. This is slightly more complicated. This is a lot more complicated. These two are just going to move stuff around. Well, there might be some logic needed there. All right, so shuffle. Move one to the right. Yeah, okay, so you can skip. So if you are the one that has a change, you don't need to... oh, wait. In which case you would need to discard this value. Okay. Does that sound right to you? Does that sound right to me? Something like this. It's going to be harder for this one because it has to pull from both sides. That's probably doable still, though. All right, so what am I doing here? For one thing, I need to change that. So, right, we're just doing the very simple logic here to check for the interrupt on this input. If there's no interrupt, if there's no interrupt, then I need to do that. So defer to this. Yeah, okay. So if there's no interrupt on you, pass along whatever happened over here to the next one in the chain. If there is an interrupt, oh, and also, oh, well then you actually just do this. Okay, so that makes more sense. All right, so if there is no interrupt, you fall through the JLZ and go here and move this along to the next one in the chain, and then start over from the beginning of your business, because your job is done at that point. If there is an interrupt, you go here and ignore whatever this one has to say. In fact, let's just explicitly discard this value, because I should be able to do that safely because of this rule. Then report your status to the next one in the chain, and then go here, and this will never execute. Because that happens up there. Okay, that looks very reasonable. In fact, this is unnecessary. Great. Okay. So, plenty of space for the extra instructions here. Now, you have two things to listen to. I could make this easier on myself by, like, making you the end of the chain and going this way, but I'm imposing an extra challenge that I want the minimum number of nodes here. Okay, so that means you need to listen to two different things. All right, so you do the same sort of thing. Instead of moving to the right, you're going to move down. So here's the interesting case. Right here, do you move... Okay, so move left nil, move right nil, if you're reporting. So that's fine. You need to interact with both left and right. All right, so the extra logic goes in here. Move left ACK, JEZ, other one. So if you've read a 0 from here, then neither of these have anything to report, and you want to report whatever this is. Yeah, this makes sense. I'm running out of space, so I might need to compact this, but I might actually just have enough. I think that's right. Okay, so let's run through this a bit. So you do the normal comparison logic, just like all the others. If you are reporting, then you discard whatever's in this port, you discard whatever's in this port, and you report your own thing to this. However, if this doesn't happen, then you check. You put this into your register, the whatever result came from over here. If both of these have reported 0, now if one of these has not reported 0, then you take that result, move it down, and go back to the loop. Problem. I need to... that fits. Okay, so I have another space for an instruction. The problem here that I detect is that I need to discard this result, because otherwise this will block on output forever, or rather these will desynchronize. And also this will block on output forever because it will desynchronize because this blocks. All right, so you, if there's something interesting to the left, move that down and also discard this value. Wait. Found a bug, because I've already read from left. The value of left is in your register. Okay. All right, that sounds right. So the interesting one gets passed along that way, move right to nil, and proceed. If you're doing the other one, then the interesting value is over here. Technically, move right nil, move 4 down would be valid here because you know what that index is. But this is more compact and more, you know, okay, sure. Because yeah, just by process of elimination, you know that it is 4 if you've reached this point in the program. You've already moved left up here, so there's no need to discard that value. And then you continue back there. Okay, looks good to me. Let's do it. It is wrong somehow. Why? All right, so I think this is the point at which I would finally actually need to debug a program. So stop, step. So something went wrong. Why? Actually, let's, I think somebody's reading too fast or something. Let's see, were those desynchronizing? So you're there, that's still valid. As long as I don't see a gap of 2 anywhere in here. All right, so you want to move a 0 there, you want to move a 0 there, you're already going on to your next one, so that's fine. You've decided that there's nothing interesting from the left. And you're moving this 0 downward. Sounds good. That's all fine so far. So a 4 needs to be written on this step. Okay, so what's going on right now? All of these have been read. You're writing a 0 there. Yeah, the interesting value comes from here. You're ready to move that. Move left into ACK. So you get a 0. Jump to other one. Yes. Move right down. Move up, down. Yes. Yes, that 4 is proceeding. And it gets to the right place, right? So the next one needs to be 3. Oh, here's the problem. Here's the problem. I need to reset... Well, no, I do reset ACK here. The problem is I reset it to the wrong value because this stays 1. Yeah, this remains 1. I need to subtract 1 from 1 rather than 1 from 0. Okay, so this program is no longer fitting. So back needs to be involved in in all of these cases? So it happened to work just by sheer luck there, but you wrote a 3. You wrote a 3 for those inputs. Yeah, because it was a 1. Yeah, I'm not remembering the last value. Okay. So... yeah, so goes from 0 to 1. Yeah, okay, so my logic, the logic I've based all of this on was had a flaw in it. So that's had effects downstream from everything from the beginning of this. All right, so this is my incorrect instruction. So that means I need to remember that value. You're the only one who's using your register for anything other than comparing these. So really, I want to... let's fix the outer ones first. Then I can think about how to do the innermost one. So what I probably want to do is... okay. Okay, so problem with what I was planning to do. This is hard to think about. Give me a second. Let me form my thoughts a little bit better before I speak again. All right, so here's what I'd really like to do. I would like to move up into AC, save, and then I'd love to do this, but I can't, because you cannot use this as one of those. But I can't do this because then I would just read the next value. So I need to save the value I read from up somewhere that it can also be used to subtract from the AC here. Maybe there's some clever way I could do that without having to involve another core, but I might have to involve other cores here. And then you have the extra complication of acting both as temporary storage for that and also passing data on to the next part of this. So my cores, I would have a lot more core usage if I did, node usage if I did that. This self-imposed challenge is unnecessary. I might abandon it in a moment, but I just want to see if like anything jumps out to me about... no, I mean, this is all the instructions I get, pretty much. Yeah, since I can't since I can't subtract back from AC, then I think like the entire idea of what I want to do here is just invalid. So if I wanted to optimize for node count, I'd have to like use this for temporary storage for that and do all sorts of crazy stuff. So I think the more reasonable way to do that is just to use these for storage, right? So if I were doing that, so how well does this work? Move up into AC. Move AC into down. Well, I'm not using back at all. Let's just mess with this program until I feel like I understand like what I want to do with the rest of it. So I do need to know the previous value. Previous value of everything, I guess, starts at 0, so I want to do one of these again. Right? Something like that? Because you need to do something different up front. Because you're going to get a different thing when I'm not thinking about this clearly. Alright, so a real inefficient way to express what I want to express here, I think, would be save, sub down, swap, move ACK, down, swap, and then proceed. That uses a whole lot of instructions in just this core, one of the simplest ones. So I really need to save this value away. I need to save this value down here, but also, right, so that's what this does, but also use the previous value from here to subtract from this. I mean, like, I think this is legitimate. Like, I think this is all phrased correctly. It looks inefficient, but yes, so then doing something like this forces me to do this big complicated thing in here, or perhaps spread across these two. But see, now you're going to have to do double duty, and you need like a whole lot more instructions that are not going to fit. I can trim this down by 2 lines. All right, let's just go ahead and do that. Here, let's keep the same initial letters just so that I know what that's supposed to be. Kind of. Alright, so I saved 2 lines here, but I've added more than 2 lines to this in comparison to how it was before. So that's gonna get tricky. Alright, so I'll fix these up. I'm not sure how close I am to being done here, honestly. Move up, ACK, save, sub down, swap, move ACK down, swap, news report. Okay, that's fine. This one's definitely going to have to get more complicated. All right, and you... move left, right. Actually, you're almost the same as this. All right, so move left, nil. So right, the difference is that you want to do this and this. I think that's the only meaningful difference between these two, and that, of course. Okay, great. What about this guy? So move up, ACK, save. Let's see how far I get here. I think I feel like I need a more efficient way to do this. I don't like those 2 swaps. But I can't move. Oh, I think I figured out how to do it. Oh boy. All right, so shoot, I've left this kind of in an intermediate state of partially being modified. I need to trim these down before I can fix this one up. So here's what I'm going to do. If I move that down, this is going to get more complicated. So you'll save away... Yeah, this makes sense. Okay. Move up into ACK, swap, move ACK up, swap. That doesn't sound right. So wait, how does this help me? Right, so you've already moved ACK down, so you don't need any of that, right? So you read this value, then you send it down here, which puts it into your ACK. Then you swap, send your back up here. Then you swap again. Actually, you don't want to swap again. That's what it is, right? Yeah, so you send the previous value, then save this to be sent next, kind of. I think I'm thinking about this right. Let's say that's right. Okay. I don't like how complicated this is getting. I mean, I do. I do as a player of this game, I don't as a programmer. Like, this is more complexity than it feels like I should have here. I'll bet there's a much simpler way to do this that's cleaner. But this is what I have right now. All right, so you just need left, right, move 0, right, move left, nil. All right, so all of these should be fine, and this should be compact enough to make all this work. Okay, so now loop, move up into ACK, move ACK down. So right now you're going to get more complicated. You need to like alternate between being storage and being a pipe to down here. That's fine. I think I can make that happen. All right, so move ACK down. Sub down. So you do want to read from here. Okay, so let's start with this. I think this is actually fine because I know... Yeah, I think it'll happen in that order, and this doesn't actually need to be complicated. It's just going to... Because I know the order of operations, this will be fine, I think. Yeah, okay, and most of the rest of this works, right? Move ACK down, sub down, JLZ report. Move left ACK, Jez O, move ACK down, move right nil, jump. This might be fine. Seems plausible, let's try. No. It's definitely wrong. Why? Did it get any right? You wrote 0. Why did you write 0? You were supposed to write 4. Okay, so why did you not write 4? When in.4, that 1 is red. Move ACK down. All right, so you get 0, swap, sub down. Zero. Move 0 left. No, this is telling me the next thing to be read. You haven't read that value yet. Okay, so that 1 is waiting. All right, so you got 1 into ACK. You've sent it over there. This has stored it. It's going to store it in back, while this waits for it to be the previous value here to be given back to it. So you've subtracted that. Oh, you're doing it backward. That's my problem. So my detection is wrong. Okay, so can I just change this to Jez? Or Jigs? Probably not, but let's see what it does. Oh, it works. Okay, that was all I needed. So I just had reversed my subtraction. So by changing that from less than 0 to greater than 0, it allowed the subtraction to happen the other way, but follow the same logic. Okay. Well, I didn't accomplish my goal of using fewer cores. I needed more. Let's see if anyone has done it with fewer than this. They certainly have. I am sure I could have like folded these bits of logic into... Probably, honestly, I could have put this here and this here if I were crafty enough about it. But like optimizing this is a whole game in its own. Yeah, a few people have gotten fewer nodes. My cycle count is more than anyone else has ever done. Okay, so my program's very slow. Like I said, I'm sure there are simpler ways to do this. I came up with a complex solution. It works, but it's not efficient. Huh. So the largest number of people found the smallest cycle count. Weird. They must have used the nodes for like, maybe there was more parallelization or something? I wonder why mine is so slow. I'm going to have to like look up other people's Can I see other people's solutions to this? Oh dear, that's not what I wanted. Oh. Well, that's what the saves look like. All right. That's cool, I guess. So like there's a server somewhere that knows what people have done, but it's not like Drod where I can just like look up somebody else's demo and see it, I guess. Oh, when I repair 9 more, something new will unlock here. Also, do I know what this is? Not really, but okay. Well, I'm going to be happy with that. I'll look at what this is. Yeah, okay, so this is a sandbox. I just get to like... Oh, fascinating. Yeah, okay, so I just get to play with this layout, implying to me that the next row is going to involve different node types. That's what I think is going to happen here. Okay. Yeah, feel like I could have done better on that, but that was the way that I came up with first. It was very inefficient, but it did work. And I kind of like the complexity, even though at the same time I kind of don't. Anyway, so that's what I did. All right, see you next time for the rest of this.